26.
What the heck is that?
Mr. Miller has promised a 5-minute video. Let's see if he delivers. And that, sir, is a transformer. Because we're doing transformations.
Ah, man.
Yes.
All right. Is that what the kids are doing these days?
Yep.
All right, let's do it.
All right. So here we have our example problem. The heights of 9 high school senior girls are recorded at the start of the school year. It was determined that the mean height of the group was 65.6 inches, with a median height of 64 inches and a standard deviation of 2.3 inches.
It looks like someone lost a shoe there.
So, at homecoming, always trying to distract. At homecoming, all of the girls showed up wearing 3-inch heels.
Whoa.
What would be the new statistics?
Are they still standing?
Yeah, I think so.
I don't know. I thought I had these huge heels once. It was so funny. I really walked. All right. So, Mr. Lewis, if they're wearing 3-inch heels, what happens to their height?
Well, it would all increase by 3 inches.
So we're adding 3 to all their heights.
Yes.
So the new mean would be
68.6.
And
inches.
the new median?
Median would be 67 inches.
Okay.
And the new standard deviation
2.3.
Yes.
Doesn't change.
Doesn't change.
So everyone went up 3 inches. Their heights didn't get any more spread out. So remember, when you're adding or subtracting a value to all the data, it doesn't affect measures of spread.
No, it does not. However, now suppose their original height was converted to feet.
So we had inches. What do you do to get feet?
We're going to divide by 12.
Okay.
Yeah.
So when we divide by 12, I sense the need for a calculator.
Yep. You're
let's
the
see what
calculator
new
guy.
mean. So the new mean, we would take the original mean and divide by 12. So 65.6 divided by 12 is 5.46 feet.
5.46 feet.
Wow. Okay.
Okay.
And the new median, we
New
divide by
median.
12 also. And the new median would be 5.33 feet.
3. And now the new standard deviation. Now,
It would be the same, wouldn't it?
no, actually. Spread will come closer together because we're dividing.
Oh, okay. So the data would shrink in. So
Yes.
2.3. So multiplication and division affect all the statistics.
Correct.
So the new standard deviation would be 0.192.
0.19. All right.
And what would the units be for standard deviation?
Feet.
Yeah, so that'd be feet, and the units for median are feet.
Yes.
All right, Mr. Lewis, we're ready for
Feet.
a review prompt. They can call in with the answer. Wait. Take a look at the data. Which was bigger, the mean or the median?
The mean.
The mean was larger than the median? Okay, so what does it tell you about the heights for the girls?
That would probably tell me that there are a few girls who are a little tall dragging that mean up.
Okay, so maybe skewed to the right?
Yes.
Maybe there's an outlier.
Yeah, we're not really sure if there is an outlier, but yes, it would definitely be skewed a little towards that right side.
All right, man. Beautiful.
Okay. All right, now we're at a bike shop. The store charges $20 to rent a bicycle, plus a charge of $3 per hour the bicycle is rented. So last Tuesday, the mean number of hours rented was 3.2 hours, with a standard deviation of 1.4 hours. Now we want to calculate the mean and standard deviation of the rental cost for the bikes.
Mr. Lewis, there are 2 steps involved.
Okay.
So you got to think of how
Walk us through it.
the rental cost is computed.
Yeah.
You got to take the number of hours times 3 and then add the 20. Could we do a little
Correct.
example somewhere?
Yeah.
So let's write examples. We're not solving the problem yet. But it's good to think about how it's being computed. So let's say you rented it for 5 hours.
All right. So then we do 5 hours times the $3 per hour. Oops. If I could make it H. Okay. So that would give us $15.
Yeah,
And then we would add the 20, which was our flat cost.
right.
So for 5 hours, it would be $35.
So when we're computing the new statistics, we got to follow the same steps. It's important. Order makes a difference. So we're multiplying by 3, and then we're adding 20 to the data.
Right.
So sometimes I like to do it in like 2 steps. Like first, what would be the statistics after you multiply by 3? And then what would be the statistics after you add 20?
Okay.
And when we're really good at this, we can do it all at once.
Well, baby steps.
All right, baby steps.
All right.
So
So we'll do the new mean for the what? We'll do for the $3 per hour.
yeah,
Okay, so I'll put a little 3 there. So if we did that, it was 3.2 hours times 3.
9.6.
Probably 9.6, right?
Right.
All right, so $9.6.
And the standard deviation.
Standard deviation, x of 3, would be 1.4 times 3, 4.2.
Yeah.
Yay.
Okay,
Mental.
so that's the middle step. And
Yes.
now we got to think about adding 20 to all the data.
Okay,
So if we added 20 to all the data,
our
the
final mean,
would be 29.6.
Yep.
But adding 20 doesn't affect the standard deviation.
no.
So the standard deviation final standard deviation would still be 4.2. So when we have problems where there's really 2 transformations combined, you can't think through it one at a time. Multiply the data by 3, these would be the statistics, and then add 20, and we get the final statistics.
Right.
Okay.
So our final answer would be out here.
So it tells me on average they made $29.60 for bike rental fees. The standard deviation $4.2.
Mhm.
Okay, good.
All right.
It is journal time.
Wow. All right. Already journal time. So here we have 2 problems. The average number of rushing yards per attempt in a football game was 4.3 yards with a standard deviation of 1.5. Suppose the data was converted to feet. What would be the new statistics? How many feet in a yard there, Mr. Miller?
3.
All right.
So yeah, multiply by 3.
Probably should know that already, but we'll throw that in just to help you out.
Okay.
And then number 2, the mean height for the flags flying in front of a bank was 45 feet with a standard deviation of 0.3 feet. Suppose the flags were lowered 20 feet to honor a past president. What would the new mean and standard deviation
A
be?
past president?
Yeah, one who died.
Oh, I thought it'd be PAST.
Well, that would be a president who was in the past.
I'm confused. Anyway, the math will be fine.
The English maybe needs some help.
All right.
All right. I'll see you guys on Monday.